We're here in the beautiful Zug, Switzerland, and we're here with a very interesting project, Radix. Nice meeting you, Piers.
Great to see you, Russell. How are you?
Yeah, doing fine. For the wider audience, perhaps you can tell us what is your project about.
Sure. So my project is called Radix DLT. It's been a R&D project for 6 years now. And the easiest way of thinking about it is it's a speedy alternative to blockchains and DAGs, directed acyclic graphs. It's our own data structure. And that comes out of the sort of research that we've been doing into how do you build truly scalable systems in a way that is also permissionless. So you can do it as a trustless, decentralized network, but you can do it in a way that doesn't have the problems that blockchains and directed acyclic graphs do with like true scalability.
All right. So your solution is also as decentralized as, blockchain is a container, is it?
Yes, yeah. So like the way that ours works is we don't have proof of work and we don't have proof of stake. But the nodes that run on the network are rewarded for validating transactions across it, right? And then we have a way of making sure that people can't lie on the network and can't validate things that essentially mislead other people or can be detected for doing so. But anyone can join the network, and the way that we've built the system doesn't rely on large amounts of computing power or large amounts of staking or any staking at all. And what that means is even small devices like Raspberry Pis can be a productive member of the network. And this all comes down again to the data architecture. If you can create a data architecture that can shard effectively without reducing the total resources required to attack the network as a whole, then you can have a small device doing a small set of the shard space and a large device doing a large set of the shard space without reducing the overall attack vector of the network, which is the problem with things like proof of work and proof of stake.
All right. So very simple. If I buy a Raspberry Pi, I can connect my Raspberry Pi to your network, or how does it?
Yeah, that's right. So practically speaking, we have a Node Runner program, which you can go to our website and click on the Node Runner link. And we're on our AlphaNet at the moment. We'll be releasing the Node Runners for anyone to download a Node Runner and try running it on our AlphaNet in a few weeks' time. And it's essentially Docker, right? So if you have Docker on your device, and you can run a Docker on a Raspberry Pi because it's a Linux device. There are then Docker containers. It's just point and click, pulls it down, and it starts running straight away, and you can start earning on our testnet, which isn't real tokens yet. It's just test tokens, but yeah, this is the principle is that it allows you to test actually running real nodes on our network, regardless of the size of those nodes.
All right. And do I have to pay to become a node, or how does it work to become in?
No, there's no payment to become a node. The consensus mechanism deals with how nodes are allocated in the system and make sure that you can't be dishonest in ways other than requiring staking.
All right. So this solution, it's faster, it's more scalable than the blockchains we know. For instance, of course I know Zilliqa a bit. Zilliqa says we have these, a few thousand transactions per second. Can you compare it? How should you compare it?
Yeah, so scalability is a weird one for people to talk about because it's hard. It's often hard to conceptualize exactly what you mean by that. So we've run our network to over 20,000 transactions per second. We'll be doing 1 million transactions per second on a publicly auditable network before the end of the year. But that's actually not the real sort of test. The real test is to look at the architecture and be able to say, this is provably scalable, linear for this many iterations until you've got the world population and you have every single device using it simultaneously. Does your architecture support that? Does your consensus support that? So the way we do that is we say, okay, instead of starting with a single vertical architecture and trying to shard it over time and then having to reallocate those shards, we start with a massively sharded infrastructure to begin with. We have 18.4 quintillion shards. So that's 2 to the power 64.
Already?
Yes. And so if you took all of the data warehouse that Google warehouses, like all of their own data, all of their third-party data, their copy of the internet they have, and divide that by our shard space, it comes out about 2 megabytes per shard, right? So they're storing videos, they're storing documents, we're just storing state data, the transactions and the smart contracts that live on top of Radix, right?
No.
So 2 megabytes per shard to warehouse all of Google's data, more than enough shard space to keep all of the transactions that happen in the world for every device and every person on that. So that's your first point, right? Wow. The second point is that your transaction throughput is very asynchronous, because the way that it works means that if I have a transaction on this shard, and I have a transaction on this shard, I don't need to have consensus between those shards, right? So because we are able to group related transactions together into the same shards, and then unrelated transactions don't occur on the same shard, so there's no consensus being done between them, which makes it massively more efficient than the current infrastructure. So if you took our maximum throughput of a single shard, 2,000 transactions per second, and multiplied that by the shard space, 18.4 quintillion, that would tell you the maximum throughput of the Radix network, which is, what is that? 36 quintillion transactions per second, which is the theoretical limit, right? So we don't like to say infinite because that sounds silly, and also there are some constraints around the fact that you can only get a maximum of 2,000 transactions on a single shard, but the way that we separate up all the transactions across it means that the majority of transactions are sort of on their own in shards, which means that you've got this incredible parallel throughput that means that you've got provable scalability.
So you don't run into problems like higher gas fees, etc. I mean, that's
no. So when the network gets more congested, then it's very, very easy to add more resources to the network. And the problem with like the things like congestion on blockchains is that the block gets filled up, right? So I really want to get my transaction in, and the block's full, and so I'm going to pay more to get it into that block. But we don't have blocks. Every transaction is done on a transaction by transaction basis, and because of the massively parallel architecture, if the throughput is too much for the number of nodes on the network, then more nodes can come into the network and trivially increase the throughput. So you don't have this sort of bidding system. You just see that all of the nodes are at their maximum capacity, but they're earning a lot of money because they're validating all of those transactions and earning the fees, which attracts more people in, free market, Adam Smith, and then these nodes are now able to add to the capacity, and the capacity can keep growing linearly. You don't ever have this problem of too many transactions in a block.
How did you actually came on this idea to I mean, all these guys are busy with blockchains, and you have a different solution now.
Yes.
How did you came about it? I mean,
so it has been an iterative process. So the company was founded in 2012 by a guy called Dan Hughes, who is the founder and CTO of Radix. And it was founded because he, in 2011, discovered Bitcoin. And the first thing he did is he likes taking technology apart. So he forked the Bitcoin source code and was like, okay, can we break this? When does this fall over? So he started doing throughput testing. Right, so like he had his own network, so he can remove the block size limits. What happens when that happens? When do you get thrashing? When does it fall over? Found that practically speaking, in a truly decentralized network, the maximum throughput of Bitcoin was about 500 transactions per second. Absolute maximum, and that's a computer science limit, not we can just throw more resources at limit. And so he was like, okay, this isn't going to scale. This isn't going to work. So then he started looking at block trees, which is like a next stage on from sharding, from state sharding. And then he was like, no, this isn't going to work either. We get a bit more transactions per second, but we always have the limit of the main chain. So if you look at state sharding, you're pushing things off the main chain, right?
That's what Ethereum is doing now with Plasma.
Right. You're pushing things off the main chain, but you still have to report the start state and the end state back to the main chain, right? So at some point, you're going to reach capacity of the main chain, and then your state sharding falls down. So it's a good sticking plaster, but it doesn't get us to global scalability. It just gets us a bit further along the road, right? So then Dan started looking at directed acyclic graphs, and this is like 2013, 2014, so before IOTA, before Hashgraph, before all of these other ones that are looking at DAGs now. And he found that this was a much more interesting structure because you have the asynchronicity, right? So like You don't have to wait for blocks. You can submit transactions at any point, and it's sort of a nice architecture that can be split up, because as the tips spread out and you get like capacity, you can then add a shard, and now you've got some tips on this side of the shard and some tips on this side of the shard, and it starts looking like a nice scalable architecture until you realize that you have a double spend problem if you can't coordinate between the sides of the shards, because my balance sits here. And if I want to spend on my new balance, and I can now spend, I can choose one side of the tips, one side of the shard or the other side of the shard, both of which that have directed acyclic graph paths back to my first balance, then I have a trivial way of being able to double spend. And the way that that is stopped is by having coordinators, which is a centralization. It's what happens with something like IOTA or with Hashgraph for that matter.
What do you think of that? These concepts?
I think the I have a lot of respect for every single project that tries to push forward the envelope in this tech space. Like I think everything is a good idea to try out and test, the problem with the centralization of like coordinators and stuff like that is you just start piling a lot of trust into a small number of hands. That creates points of failure that this whole sort of movement was about sort of preventing. It was all about like, how do we create a anti-fragile system that has no center, that doesn't have a central point of failure. And even if you say, oh, that central point of failure is 12 people or 21 people or 39 people or 100 people, it's still a central point of failure to the overall network. How do you create something that is truly anti-fragile? It has to be decentralized. And so that's these are okay solutions to the problem set that we have now until a better solution is able to be come up with.
You don't have these coordinators. You don't have a central point of possible.
No. No.
All right.
Exactly.
All right. Just a few more questions. I mean, are you planning an ICO actually for your or?
This is the perpetual question. The question we get asked a lot. No, so we're not planning an ICO. We have, Dan has bootstrapped it to now. Sort of largely self-funded. There's been a few sort of angel rounds and things like that into the project. But the intention, so Radix is actually quite a lot of different things. So there's the scalability layer, but then we've also gone one layer up and said, what kind of functionality do we need to build into the core of the platform above consensus that actually makes the platform useful as a public decentralized network? One of the things that we thought was really important was decentralized exchanges, right? Okay. So into the Radix protocol itself, at core, is an order book system that runs a decentralized exchange protocol as part of every single node running the network, right? Okay. What this means is you can buy and sell native crypto on Radix between the currency pairs of whatever tokens are created on the Radix network. We will be launching the Radix token across our own decentralized exchange when we go live. So there is no ICO, and you won't actually be buying the tokens from us. The tokens get generated by the system according to how our economics operate, which is a much longer conversation that I don't want to bore you with now. But yeah, essentially, we'll be going live in Q4. And there is the ability to sort of register your interest in Radix tokens on our website, but it won't be an ICO. It won't look like the traditional model that you've seen so far.
All right, and you haven't valuated the token yet.
No.
All right.
And we haven't done a pre-sale, and we haven't done a pre-allocation. We're not giving any discounts. This is all about when it goes live, you can buy it and use it.
Very simple, actually.
Right.
Last question. This could. In theory, also be a competitor of the Visa and Mastercards. Of this world, or
yeah, for sure. Transaction. Yeah, no, absolutely. So, we're already running. If you go to explorer.radixdlt.com, then you'll see that our test network is already doing 2,500 transactions per second, which is more than Visa does on a daily basis, right? So yes, it can definitely be a new clearance and settlement layer for financial transactions. The real question then comes in is what does that interface with the real world that we recognize outside of the crypto world to be how all commerce is done? So what does the fiat interfaces look like? How do merchants get accounts, and how do you do that clearance and settlement outside of the rails that have been created with a great infrastructure and almost monopolistic ability to charge whatever they want with things like Visa card and Mastercard? How do you break that? It's very, very difficult. difficult. And so it's not something that we're looking at as like an immediate target. It's something that will emerge as a result of our network being an incredibly useful part of infrastructure for the companies that are building today. And as that then moves through to the real economy and real people using our technology, not even knowing it, right? Because a company comes along, says this solves a problem for me, decides to build on Radix and goes and serves their customers. And that it's underlying enabling technology, yes.
All right. Thank you very much, Piers, for this interesting lecture about Radix, and all the best with your product. I mean, very interesting. So people can go to
radixdlt.com. So that's RADIX DLT. That's D for Delta, L for Lima, T for Tango .com.
All right. Thanks you. Thank
Lovely.
you.
Thank you very much.